Hello, algebra. So we are starting chapter 3, which is all about functions and graphs of functions. So our essential question is, how do you determine whether relations are functions, find domain and range, and identify the independent and dependent variable, which I'm sure you guys have heard in science before. So first things first, a relation pairs inputs with outputs. When a relation is given as ordered pairs, the x coordinates are the inputs and the y coordinates are the outputs. A relation that pairs each input with exactly one output is a function. All right, that is what makes a function. So we have a couple different ways we could see these relationships. Let's see if I can zoom in a little bit. There we go. All right, the first one is just as coordinate pairs. So we've got -2, 2, -1, 2, 0, 2, 1, 0, and 2, 0. We wanted to ask, is each x value listed only once? Well, -2, -1, 0, 1, and 2. Is it listed only once? Yes. So this is a function. So now I'm going to take my coordinates and put them into a table. So -2, 2, -1, 2, 0, 2, 1, 2, and 2, 0. Is each, let me move this guy over, is each x value listed only once? And it's important that they're listed in order. All right, it's important they're listed in order. Are they listed only once? Yes. So this, again, is a function. And then the last kind that we'll see is this input-output table. So I just listed out all my points. I don't repeat values, though. All right, don't repeat values for this. So -2, 2, -1, same 2, 0, same 2, 1, 0, and then 2, same 0. So I've got my arrows drawn on here to show how they pair up. And the question we have to ask ourselves is, does each x have only one arrow? Yeah, each x has only one arrow. So again, this is, yes, a function. So now I'm going to move my sticky note down here. We want to ask ourselves, does each x value, is it listed only once? So we've got 4, 0, 8, 7, 6, 4, 4, 3, and 5, 2. Well, wait a second. I think I said a 4 for my x and another 4 for my x. So is it listed only once? No. So this is not a function. So then for my table here, I would have 4, 0, and again, it's important to have it listed in order. So then we would do 4, 3, because we have to have our x's by each other, because they're the same. And then we would want to do 5, 2, and then 6, 4, and then 8, 7. So it's a really bad 5. There we go. So are the x values listed only once? We have 2 of them. So this one is not a function yet again. And then for our input-output tables, we have a 4, 0, so I draw my arrow, and then we have a 4, 3, and then we have a 5, 2, a 6, 4, and an 8, 7. Do we have only one arrow from each 4? No, because we have a double arrow right here. We can see we have a double arrow. So this is not a function yet again. Now, what if we have a graph? Ooh, you couldn't see that. Oh, that's really terrible of me. Okay, let me give you a second. I'm going to zoom out so that you can see everything a little better. All right. What if we're given a graph? Well, if we're given a graph, then we want a function where no vertical line passes through more than one point. We call it the vertical line test. I abbreviate it as just VLT. So for our first one here, I'm going to take my vertical line, aka my pencil, because it is a vertical line, and I'm just going to run it across. Does it touch more than one point? No, this one does not touch more than one point. It touches exactly one at any one time, so this is a function. This one is a function, and we can see that with our little dashed line here. It's got 1 point. So for this one, if I take my pencil and I run it along this function, it touched 2 points, right? There's a point right here, and there's a point right there. It touches 2 points. So this one fails the vertical line test. I touch more than 1 point, it fails, not a function. So now when we come down here, I'm going to take my pencil, and I'm going to run it along. Oh, I just touched 2 points here at 2. Right? There's 1 point, there's another, and there's another spot right here at 5 that also fails the vertical line test. So this one is not a function. It fails the vertical line test. So then when I come over here to this next one and I do my pencil, I touch no more than 1 point. I can draw my little vertical line there. So this one passes the vertical line test. It's a function. So I want you to try that out with the next 4 on this page, which are functions, which aren't, right? Which are functions, which aren't. Double check your work. You should have gotten that this one was a function. It passes the vertical line test. This one's a function. It passes the vertical line test. We're not doing horizontals, we're doing verticals. This one fails the vertical line test. It touches 2 points at any one time. And this one passes the vertical line test. So even though they might look a little weird, they are functions. All right, let's check out domain and range. So domain is the set of all possible input values, all possible x values. I kind of have drawn it here with that long O, domain, to remind you that it's the x, it's the horizontal, all right? And then the range, I've done a little vertical A to elongate it. It's the set of all possible output values, okay? So let's just take a look right here first. We have just some points on a graph. When we just have points listed, all we have to do is list the values. So for our domain, this point is at the x-coordinate -3. This point is at the x-coordinate -1. This one's at 1, and this one's at 3. So my domain is -3, -1, 1, and 3. That's it. Try to list them in numerical order. It's always better. For range, we just want to see where we are for our y values. So this one has a y value of -2. This one is right on the x-axis, so it has a y value of 0. This one is up here at 2, and this one's up here at 4. So our range is -2, 0, 2, and 4. So when we have points, like with this one, which I want you guys to try next, we're just listing them out. So take a minute, pause the video, try this one out, see what you get for domain and range. All right, so for domain, you should have gotten 1, 2, 4, and 5. For range, you should have gotten 0, 1, 2, and 5. We have a couple of those that repeat, so even though there are a total of 6 points, we don't have 6 total numbers because some of those repeat, and we don't repeat them. All right, for this one right here, for our domain, because this has a line, there's actually an infinite number of points in between. So we have to look at the smallest and the largest, and it's like we need them. We need a compound inequality. We were just talking about those last week. Isn't that great? It's like it sticks with us and it never goes away. I know you're stoked. So our smallest value for our x's is at -2 here, right? Because this is -3. And then the largest x value is up here at 3. So I've kind of drawn that. It's like if you could squish the line down so it was just on the x-axis, where would it touch? Well, it would touch everything between -2 and 3. And it's actually equal to it. We've got nice closed dots there. So we've got equal to's as well. So then for our range, our smallest range would be right here at -1 on the y-axis. And the biggest one would be up here at 2, right? It's if we squish that graph so it only touched the y-axis, where would it touch? It would touch everything between -1 and 2. So I hope those kind of make sense. I want you to try out number 7 down here, this one. All right, try out number 7 down here. See what you get for domain and range. All right, domain, you should have gotten everything between 0 and 6, right? So for the domain, it would be 0 is less than or equal to x, which is less than or equal to 6. And then for the range, you should have gotten 0 to 6 as well for the y. All right. The last one we're going to try together is this one right here. So for domain, our smallest domain, actually, it starts right here, right? That's where it starts. And that coordinate is 0, 1. So our smallest x value is going to be 0. And then this arrow means it never ends. It keeps going on and on and on forever and ever and ever. So that means that our domain is going to be everything bigger than 0. Everything. So it's just x is greater than or equal to 0. Everything greater than or equal to 0. So then for our range, this one doesn't start here at the origin. So the range can be a little tricky sometimes, but our coordinate here says the smallest y is 1. So even though it keeps going forever and ever and ever, so we have everything bigger than 1. So y is greater than or equal to 1. So now let's take a look at this one over here. I want you guys to try this one out. Pause the video, try it out. We'll go over it in just 1 sec. All right, so domain for this one, all possible x values. You see how it's got arrows in both directions, right? It keeps going smaller and bigger. So this one is just all real numbers. All real numbers. It touches every x value. It goes forever and ever and ever. So then let's look at our range. All right, our range has the smallest value down here, which is at 0. So y is going to be greater than or equal to 0. And again, it keeps going forever, up and up and up forever. So it will be any number that's greater than 0 or equal to 0 for y. All right, our last page, independent and dependent variables. I know you guys know this from science, at least a little bit. So the independent represents the input values. When you're in a word problem, it's the first thing that you do, okay? It's the first thing that you do. And then dependent is whatever happens because of the first thing, right? It depends on the first thing. So for our first one right here, we just want to identify what's the independent and dependent. This is the number of quarters you put into a parking meter affects the amount of time you have on the meter. Well, what did we do? What we did was we had some number of quarters, right? And then what happened? Well, it was the time on the meter. That's what happened. So for our next one, the amount of your paycheck is determined by the number of hours you've worked that week. Take a second. What did you do? What happened because of it? All right, so your independent was your hours worked, right? Because that's what you had control over. That's what you did. And then the dependent was the money on your paycheck or in your paycheck. So for this one down here, you have a function, y equals negative 3x plus 12, and it represents the amount y in fluid ounces of juice remaining in the bottle after you take x gulps. So that means we have control over our number of gulps, right? And the amount left, I think it's the amount of juice left, is dependent upon how many gulps you take. So they're telling us our domain is 0, 1, 2, 3, and 4. So that is our domain. So I'm just plugging that in for my x values. We want to find the range. I've made this table here that includes a little section for us to work it out so we can see. So first thing I'm going to do is I'm going to plug in 0 for my x. Well, that means I've got negative 3 times 0, which is 0, plus 12. So my output is 12. So that's my first part for the range is 12. The next one is going to be 1. So negative 3 times 1 is negative 3, plus 12 would give me 9. All right, our next one's going to be 2. Negative 3 times 2 is negative 6, plus 12 is 6. The next one's 3. Well, negative 3 times 3 is negative 9, plus 12 is 3. And then 4. Negative 3 times 4 is negative 12, plus 12 is 0. So this is my output, 12, 9, 6, 3, and 0. That is my range. That is my range. Some of you would say, well, isn't it everything in between? And I would ask you, can you take a half a gulp? I cannot. So no, it would not be anything in between. It would be exactly this because I can't take a half a gulp. I just can't. It's not physically possible for me to do. So I hope you're feeling pretty comfortable with range, domain, independent, and dependent variables, and what is and isn't a function. Skills practice is posted.